Terracotta is scalability and availability for Java applications. Scalability and availability work best in an add-a-brick fashion. I want to just keep adding boxes as I scale. Why is that? Well, these boxes cost a couple of $1,000s each. And that's a lot better than one big box that costs a couple of $1 million each, right? But the challenge in that is developers have to sort of code an application and recode an application over and over again. As you add bricks, you have to adjust to the fact that more bricks means more overhead in communicating across servers. And so Terracotta, we decided to go with a transparent model to the add-a-brick scalability story. Basically what Terracotta is doing is if you can run an application where the hard drive is pulled out of the machine and out onto the network, why can't Terracotta take that same application and pull its memory? If this were a chip, like a piece of memory, why can't Terracotta pull the chip for RAM out onto the network? Terracotta is to memory like network file servers are to disk. When do I use this? When do my development teams use this? And when do they use a database? When do they use this? And when do they use a file? When do they use this? And when do they use things like Tibco or service buses? And the short answer is scratch data. Scratch data is sort of like your Scantron test back in high school. It's a multiple choice test. You have A, B, C, or D to answer to the question. But if it's a math test or a physics test, you need a piece of scratch paper out on the side to compute your answers to each question. And that scratch piece of paper, the teacher's not going to collect it at the end of the test. But without that scratch paper, you can't really take the test. That scratch paper is transient in time. You don't need it forever. And when it comes time to grade, your teacher just feeds the Scantron through the system. But that scratch paper is how you actually succeed or fail at the test. And so Terracotta is the scratch piece of paper. The database or the file system is the Scantron. In fact, there's a case study I'm really fond of, a customer of ours who actually had an online test-taking system. So every test answer, question 1, you answer A, question 2, you answer C. Each answer discretely was written to the database, and the database scaled linearly with the number of test takers. When it was time to take the system from 5,000 users to 10,000 users, the database scalability price tag was going to be $2 million. And with Terracotta, the solution was to take the test, keep them in memory until the test-taking session was over, and then flush only completed exams, all 50 questions if it's a 50-question test, flush them all at once to the database. And what they found is they reduced the database utilization by 70%. And they, in fact, did not need to buy more database server licenses or more infrastructure to run the database server on in order to handle that scale and that volume of workload. And they had completely decoupled their application scale. They were back to this add-a-brick model where there was a database underneath, but now they could actually keep going, where without Terracotta, the database was at 70% utilization. We freed that for them and took them back down to less than 30%. And it was done in a transparent manner. So network-attached memory, basically it's a place to store scratch data, lets you offload your database, and lets your developers get back to focusing on business logic and new features and functions.